Hi students, hi, welcome to my class today. Okay, for 3P6, please enter your name. Please type your name in the comment chat and also the index number so that you record your attendance. Afterwards, I'm going to take your attendance. So please remember when you come in, please write your name, type your name and your index number. Okay. All right. Okay, today is the last class of this week. Okay, so I'm sure you're very happy that it's going to be the last class, but it doesn't matter. It doesn't mean that learning has to stop. All right. So I'm going to continue teaching as well. So I'm going to have some lessons also during the holidays, and I will post it. I will give you the notification, or if you have subscribed to my channel, you will find that you will be notified whenever I go live. So I'm not sure of the dates when I'm going to have the class, but if I do, I will let you know, okay? And also if you're subscribed, you'll get the notification. Okay, so before we start today's class, let me check whether we have done the previous one. Okay, I'll share my screen here. Okay, can you see this? Okay, Sherlyn. All right, Sherlyn this year, Yong Hao Yi, Tayuka. All right, okay. Let me check here. All right. This is what we're going to do today. We're going to explore the relationship between the number of moles and the volume of gases. All right, now, previously, all right, let's check what we've learned. We have learned the Avogadro number. All right, I'll just scroll up here. We have learned the Avogadro number, and we also seen how it's useful to let us know how many particles there are in the one mole of substance. Okay, so let's explore this before let's see what we have already learned. Okay, then we also calculated the molar mass. Okay, molar mass of the substance. Okay, now before we start today's lesson, today we're going to explore the relationship between the number of moles and the volume of gases. So today we're going to learn about gases only. Means the this one mole of gas, right, is going, if I release it into the air, right, how much of space is it going to occupy? So it can be hydrogen gas, it can be oxygen gas, it can be helium, it can be nitrogen dioxide, it can be sulfur dioxide, as long as it's a gas. So today we're just dealing with gases. Okay, now before we start lesson, let's see what we already know. All right, let's see what we already know. Let's revise first. Now you have learned earlier on 1 mole, all right, 1 mole of the substance, no matter what substance it is. It can be copper, it can be a molecule of any sort, or it can be ionic substance, a salt, okay, of any substance, will have 6.023 times 10 to the power of 23, whatever substance. Let's say if it's copper, then it'll be atoms, okay? If it is, let's say, water, right, it will be molecules. Okay, now, yeah, good. Keep the attendance coming in. Please type your name and your index number. Okay, so it's easy for me to record it afterwards. Okay, next one. If I have salts, let's say sodium chloride. Sodium chloride is NaCl. All right, 1 mole of sodium chloride. I will have this much of sodium chloride ions. Okay, now this is what I already know. This is the first thing we learn. All right. Now, the second thing we learn is the molar mass. What does that mean? It means that in 1 mole of the particular substance, right? Let's say copper, the mass of 1 mole, the mass of 1 mole will be 64 grams. Yeah, this was yesterday's lesson. So why 64 grams? This is actually the value from the relative atomic mass. Yeah. So because we learned it before, the RAM, relative atomic mass of copper is 64. It just means that if I have 64 grams of copper, it should be 1 mole. Okay, now next one. I just maximize my screen a little bit. Okay, next one. If I have 1 mole of water, which is H2O, 1 mole of water, of course, I will have also 6.02, not 23, 6.02 times 10 to the power of 23 molecules of water. But what is the mass? How heavy is that? How heavy is 1 mole of water? Okay, so in order to know this, you have to find the relative molecular mass of water, which we have also learned yesterday. Relative molecular mass of water is, so you know the formula H2O. You also need to know that oxygen is 16. That means 16 times heavier in mass compared to the standard unit. The standard unit is 1/12 of carbon. Okay, 1/12 times the mass of one carbon atom. So here, 2 times of 1, because hydrogen is 1, oxygen is 16, all right? So you have 18. Now, this one RMM or RFM has no unit because it is a comparative value. It's a comparative value, okay? You compare it against a standard. So there's, you don't put gram, you don't put anything there, just put 18 on it. That means it's 18 times, 1 molecule of water is 18 times heavier than 1 unit for comparison, which is 1/12 of the carbon atom. Okay, now, then 18 means here, the 1 mole of water will be 18 grams. Okay, the number's the same, the number's the same. So this number is called the molar mass, okay? The molar mass is gram per mole. Gram per mole for water is 18. One more thing, okay? The next one, just now we saw the 1 mole, just now we saw the sodium chloride. So 1 mole of NaCl. 1 mole of NaCl will be how much? So you take the mass of sodium, this is RFM because it's a ionic substance, RFM of NaCl. You must take Na is 23. Okay, chloride is 30. The chlorine is 35.5. So you add them up together, you will get, how much is that? 8.5, 58.5. Okay, again, no units. So here you will find that 1 mole of sodium chloride will weigh 85.5 grams. Okay, so basically, I want to put into perspective for you lah. If I give you 58.5 grams of salt, sodium chloride, okay, I give you maybe I put in a small bag for you I give you 1 bag, right? Theoretically speaking, this is considered 1 mole, okay? And inside that, whatever you see there should be 6.02 times 10 to the power of 23 units of sodium chloride ions. Okay, so that's what it means. What you have learned yesterday, all right, by the 2 hours that we had a class. So this is what you already learned, all right? Now today we further expand this knowledge to include gases. Okay, here of course we know copper is not a gas. This is solid. Water is what? A liquid, and sodium chloride, this is salt, this is also solid. So we don't have a solid, we don't have a gas example here. Okay, so today we're going to explore about, let's say, oxygen gas. Okay, as you know, oxygen is in a form of gas, right? If I take 1 mole of oxygen, 1 mole oxygen, right? And I release it into a room. That means the room has no other gases, just oxygen on it. All right, 1 mole of oxygen will occupy how big the space? How big is the volume of 1 mole of oxygen? As you know, the space in between the particles of gases, they are very big. So they can actually occupy quite a big volume, okay? The spaces in between the gases, the space is actually quite big. So if I give you 1 mole, the 1 mole has already got 6.02 times 10 to the power 23, which is already millions and millions of molecules. And I release it into a room, which is vacuum, right? It's going to spread all over and it's going to fill up the space of the entire room. So that will be how big. That room will be how big. So I'm actually now I'm going to count the volume of the gas. Okay, if it's 1 mole. So what is the volume of the gas in 1 mole? This is called molar volume. Okay, so again I tell you, if I have 1 mole of the gas, right, oxygen, how much space does it occupy? So that figure or that value is called the molar volume. Okay, let's go back to the text. Let's look at here. Now, what is the molar volume? Okay, scroll down here, scroll up here. Okay, so the molar volume, right? So we're talking about gases now, just gases. Molar volume is the volume occupied by 1 mole of a gas. I give 1 mole of gas, all right? So how big is it actually? How much volume is it going to occupy? Now, how much volume it's going to occupy is dependent on the temperature actually, and also dependent on the atmospheric pressure. Because you learned earlier, now if you look at gas, because they are particles, if it's hotter environment, let's say it has received more temperature. Okay, let's say I'm talking about one gas here. Let's say at a certain temperature, let's say this temperature is 10 degrees Celsius. Quite cooler, even cooler than Genting, right? This temperature. So the particles will move out faster or slower, faster or slower. Fast or slow? These molecules will move faster at a, let's say 10 degrees Celsius. If I compare with another one, another sample of gas, right? Same space in between, but this gas is, let's say, at 30 degrees Celsius. Which gas particle will have more energy? 10 or 30? Okay, they are both moving. All particles are moving. Right, they have energy, right? Even though it's more or less, the difference is more or less only. They all have energy. Even for solid, they have energy. So they are moving now. One sample at 10 degrees Celsius, another sample at 30 degrees Celsius. Which sample will have more kinetic energy? That means which particle will be moving faster? Which particle will be moving faster? Is it 10 degrees Celsius or the 30 degrees Celsius? Okay, let me look at your response. I will check your attendance later, but please make sure you write down. 30. Okay, Cheryl says 30, right? Okay. Now, is anyone who would like to come into my studio and you can actually ask questions? You can open your mic. I'll give you the link here, all right? But I can't have too many people, all right? At maximum, at most, it's only about, I think, four people can come in, 4 or 5 only, So I'm going to give you the link here. So I'm going to copy and paste here. Anybody who wants to come in, all right, you're most welcome to, but please just ask questions related to the studies, right? Ask questions only. I'm going to copy and I'm going to paste it here. Okay, ZN also said 30. All right, let me check. I mean, paste over here. If you want to come in, all right, and you ask questions, I am most welcome to. Just click on this thing called StreamYard. All right, okay. Now, let me go back to the question. 30. Yes, you are right. All right. When you have a higher temperature, because it absorbs more energy, so this particle will be moving faster. So when they move faster, that means it has more energy. And what happens is it's going to move further away. That means the volume will change. When you change the temperature of a gas sample, the volume will actually be different. This one will occupy more space because the particles are colliding at a higher rate. So these particles actually moving further away. So that means the volume 会比较大. The volume will be bigger if the temperature is warmer. Okay, the same amount. We're talking about the same amount. Let's say this one has got 6.02 times 10 to the power of 23 molecules. Let's say this is 1 mole. Okay, this is 1 mole. And this one is also 1 mole. We're talking about the same number of particles. This is also 6.02 times 10 to the power 23. So you have the same number of particles, but the only difference is different temperature. If you have 10, you have 30. The difference here is for 10 degrees Celsius, the particles will have less energy. So they are moving, of course, still moving, right? But not as vigorously compared to 30. So the space they occupy will be less. Okay, but if at a higher temperature, because it absorbs more kinetic energy, so there'll be a colliding a frequency that is much higher. So they will be pushing away. That means the space will be much bigger. All right, so to understand this concept, when the temperature is warmer or higher, you find that the volume will expand. Okay, which is, you know, 膨胀, isn't it? It will expand. When you heat up something, it will expand because of the theory of the kinetic energy, we call it the kinetic energy theory, right? Where you have kinetic theory, right? Where the things will move faster. Okay, now let's go back to here. So now we've got 2 conditions actually. Volume dependent on the temperature and also the atmospheric pressure. So now here it says, let's go back to here, sorry, it's a bit slow, right? Molar volume is the volume occupied by 1 mole of gas. So I give you 1 mole of gas, how much is the volume? That's all, right? That's what you need to know. And it depends on the condition. The volume, like I said, depends on condition. That is, if it is 2 different types of condition. So now I'm going to learn 2 different types. 一个是 room condition. Room condition, as you know, the temperature is about like now, right? We fix it. Because room condition is different from every country, isn't it? Sometimes you go and measure it in a cold country, of course the room condition will be cooler. If you're in Malaysia, it'll be warmer. So we fix it. The scientists have fixed it. So when we say room condition, it means here, 25 degrees Celsius. Here. Okay, now look at the second one first. Room conditions refer to the condition where the temperature is at 25 degrees Celsius. Okay, and the pressure is 1 atm. 1 atmospheric pressure. 1 atm means it's 1 atmosphere. That means it is this is the pressure that we experience at sea level. Okay, we are at sea level now. We are not up in the mountain. We are not in Genting. Neither are we at Everest or Kinabalu mountain. As you go higher, right, as you go higher to the different areas of the world, you will find that the pressure actually drops. So when you're on top of a very, very high mountain, the temperature, the atmospheric pressure will be lower than 1. It'll be 0 point something. Okay, I can't give you the exact because I didn't really check on it, but it will be lower than 1. So 1 is considered as sea level. So Ipoh is not very high, isn't it? It's not as high as certain cities, or certain countries, or certain towns in the whole entire other worlds, other countries. So you have 1 atm, right? Room condition means 25 degrees Celsius. So don't take 30, don't take 28, all right? Even though now maybe 30 or 28. Now another one is STP. STP stands for standard temperature and pressure. What is the temperature? If it's called standard, that means 0. As if you freeze it. Okay, you put the gas and put into the freezer. But it doesn't freeze. Gas has a very low, what do you call a freezing point. It will not freeze. It will still be gas. It will still be gas. You put in the freezer, it will still be gas of 0. You put in freezer of 0. And then the pressure is also 1. So this is STP. So when I say STP, the condition here is 0 degrees Celsius and 1 atm. If I say room condition, it is 25 degrees Celsius and 1 atm. Okay, so now the question will ask you based on these two conditions. If I give you this amount of gas, 1 mole, all right, in room temperature, it will be, what is the volume? What is the volume going to be if I put it in room temperature? Or if I give you 1 mole of this gas, I put it in the freezer at 0 degrees Celsius, that is the STP, what is the volume? Okay, so they give you different mole, maybe different mole. I ask you to calculate the volume of the gas. Okay, so here, how much is it? 1 STP, that means how much is the space? Okay, over here. Let's go back to here first. Yeah, okay, room conditions or STP. Now in STP, scientists have already discovered, okay, no need for you to do experiment, just take the figure. In STP, they say that 1 mole of whatever gas, it can be neon, it can be nitrogen dioxide, it can be oxygen, it can be hydrogen, it can be helium, anything. It will occupy fixed already. Never change. It's going to be this much. 22.4 decimeter cube volume, the volume. Okay, what is decimeter? 1 decimeter is actually 10 cm. 1 decimeter, 10 cm. So that means 1 decimeter cube is how big? How big is the space? Okay, I give you an idea. 1 decimeter cube is like you take a ruler. Everyone go and grab your ruler. And see how long is 10 cm. See how long is 10 cm. Okay, see how long is 10 cm. You take a ruler. I got a ruler here. All right, 10 cm. Okay, so 10 cm. 10 cm is like this only. From here to here. Yeah, from here to here only. Okay, 10 cm. You try to draw a cube. All right, this is 10 cm. 10 cm. Then 10 cm height. Draw another cube here. Okay, yeah, draw another height. This is 10 cm. And 10 cm width. So imagine you have a box like this. 10 cm by 10 cm length by 10 cm width by 10 cm height. All right, imagine you have a box in front of your face here. This is the volume of 1 decimeter cube. This is how much space is 1 decimeter cube. Okay, or if I don't want to measure in decimeter cube, if I put in cm cube, what is my answer? 1 decimeter cube 会等于多少个 cm cube? Anyone come in and answer? If not, you type in the chat there. All right, I want some interaction. I'm sure I'm talking to the 4 wall now, because it's not like Google Meet, I can hear your voices, right? But if you come in, it'll be good also so that I can have a bit of interaction. But if you don't want to come in, it's still fine, right? But you type your answers here. So if it is like this, Then I have 1 decimeter cube is equal to how much? Okay, how to find the volume first? Remember how to find volume? How to find volume? Length times width times height. Correct now? You need 3 dimensions. So if it's in dm cube, okay, let me write this one first. I don't see any answers yet. So maybe the response is a little bit slow because of the delay. So let me write this one off first. Okay, we have some time. All right. So if in terms of dm cube, I want to find the volume of this cube, okay, is 1 dm. 10 cm is actually 1 dm. So if I don't want to put 10 cm here, it's actually 1 dm. 1 dm, 1 dm, 1 dm. Okay, 1 dm decimeter length, 1 dm 1 decimeter of width, and also 1 decimeter of height. So 1 dm times 1 dm times one another dm will be, okay, sorry, I need to write this. Yeah, okay, right. 1 dm, so 1 times 1 times 1 is how much? 1 more, right? Yes. dm, how many times? How many times of dm there? I have 3 times, right? So dm cube there. I have 1 dm cube lah. This is this big lah, right? About this only. About 10 cm length, 10 cm height, and 10 cm width only. This is the 1 dm cube. Alright. Now, if I don't want to put measurement of dm let's say I want to put in cm cm is actually 10 Okay, can you give me the measurement or the volume in cm cube? This is also 10 and then this is also 10 That means what is the volume in cm cube? Do I have any answer? Let me check. I have to move this aside and see answer. Okay, yeah, just came in. Okay, Irene just came in. I saw that. Cheryl got answer for 1. Okay. So now how? If I want I don't want. Okay, Zian, you got the answer here. All right. So if I do not want dm, I put 10 cm times 10 cm, right? So times 10 cm, I will get 3 zeros there. 1,000 watts. What is the unit? Cm cube, because of 3 times. So actually 1 dm cube is equal to 1 cm cube. 1,000 cm cube. This is about actually 1 liter, you know. So this space, if you talk about 装 water okay, put water inside this is actually holds about 1 liter of water. 1,000 cm cube is actually 1 liter. Okay, same thing. So if you have a box here in front of you, just measure 10, 10, 10, isn't it? You imagine there's a box here, you go and put water inside there, 装满它, put until full. How much water will you have there? This is actually 1 liter. This is 1 liter of water. But in our gas, we don't count liter. We use this measurement. We use decimeter cube or centimeter cube. Okay, we use that in terms of gases. But in water, you can put liter, no problem. Okay, so gas, we don't normally put liter. We put decimeter cube or centimeter cube. Okay, now go back to the lesson. This is how big. I just want to give you an idea how big is 1 decimeter cube. So scientists have said that if I give you 1 mole of gas, don't care what gas, at STP condition, STP, that means 0 degrees Celsius. At 0 degrees Celsius, right, at 1 atm, it should occupy 22.4 dm cube. That means this box here, only 1, isn't it? You put another 22.4 more. Then you just pi all the boxes here. That is the space occupied by 1 mole of your neon gas at 0 degrees Celsius, which is called STP. Okay, don't think it will freeze. Actually, gases do not freeze at 0. Okay, neon gas, none of the gases freeze at 0. Water freezes at 0 only. But if you talk about gases, carbon dioxide, oxygen, they don't freeze at 0. So if in the freezer, all right, your gas is still there, it will still be in gaseous form because the freezing point for gases is way lower. It's negative, 100 or 200 something. Okay, so it still be gaseous form. Now, same thing. If I have nitrogen, I have 1 mole of nitrogen dioxide gas, NO2, it will also occupy the same amount. So this is fixed. If it's STP, STP standard temperature and pressure, 1 mole of gas will always occupy 22.4 decimeter cube. Or if I do not want to put like this, I put in that centimeter cube also can. 22.4 要乘 3 zeros. 4 0 0 1 2 3. Yes, 22,400 centimeter cube. Okay, but of course this is SI unit lah. You put decimeter cube at 22.4 lah. Okay, unless it's less than 1,000, the answer later you do calculation lah, then you can put centimeter cube because the number is too small. It doesn't. It means the number is very small, less than 1 decimeter cube. Then you can put that centimeter cube. Okay, now what about the next condition? You need to remember two conditions. They will not ask all more than that. You only have STP or room condition. The questions are: if room condition, it means 25 degrees Celsius and at 1 atm. Okay, remember that. So this is a warmer condition. So we say if it's warmer, so the volume will be bigger, isn't it? All right, just now was 0 degrees Celsius, you get 22.4. Now if it's 25 degrees Celsius, it's warmer. So your kinetic, the particles, the gases on the molecules will receive more energy because it's warmer. So it will move faster. So it move faster, it will collide more with the particles, and it moves further away. So you have a bigger space. Your volume will expand. Okay, so now if 1 mole of the same gas, neon gas, and you apply it in room condition, you put it in a room condition, it will occupy a bigger space, and that will be 24 decimeter cube. Okay, so this is also fixed. So you only need to remember 2 numbers only. In fact, no need to remember. Question will also give you the number. Okay, so you say 1 mole of whatever, or you call it molar volume. Molar volume. This number is molar volume. Molar volume is 22.4 decimeter cube, or molar volume is 24 decimeter cube. This is at room condition. Okay, so next one, 1 mole of nitrogen oxide dioxide gas, you will also have the same, don't care what gas it is. As long as it's 1 mole, it will occupy the same space. Okay, the volume will be that much. Understand? So in that case, you understand the concept, all right? Now, what kind of questions will they ask you? Okay, so very simple. Again, it's like mole and this one. Everything also got to do with mole. So you make sure you understand the concept very well. Okay, what kind of question they ask you? They ask you like this. I give you, this one just now. Okay, I give you 1 mole or whatever molar, X mole of gas, right? Whatever gas, it will occupy how much space? I give you this much. Maybe not 1 mole, I give you 0.5 mole. Your 0.5 mole of this gas, if I put in STP condition, all right, it will be how big the volume. Or I can give you a 0.5 mole of this particular gas. If I subject it to a room condition, okay, not STP, now room condition, what is the volume going to be like? Okay, that's one way. That's one way they can ask you. Another way is opposite, terbalik. They give you the decimeter cube, they give them volume. I tell you, okay, let's say how many volume, right, decimeter cube, let's say 3.5 decimeter, let's say 50.4 decimeter cube of the gas. Inside there will have how many mole? Okay, I give you the volume. You find the mole for me. This is the second type of question. So that can be here. We're going to learn afterwards. We learn with examples. Okay, again, it's easier to do examples. I give you either I can do 2 things, right? With this, I give you the mole. Okay, you find inside there what is going to be, what is the volume? This mole will occupy how much space? Or the other way around. I tell you this gas got how much volume. You tell me actually inside there is how many mole. So, 换来换去, change. Okay, either dm, you can find a mole, or I give you the mole, you're going to find a dm cube. Okay, right, now let's go and look at some questions. Any questions so far? Any questions? Just type there, you say okay means okay, right? Cheryl, yes, that's right, 1,000. If you just type there okay, that means I can proceed. I can go and look at some questions, right? Let's teach you how to do the questions. Is that all right? Just type in okay. Or just type in 1. 1 means okay. 1 means good. All right, means good to go. Okay. So actually, I need to wait for your answer because I'm looking at your response. It's come a bit about 10 to 20 seconds later. All right. Alright, so let me continue. Yeah, I can see. I see some okays. All right, good. That means I can carry on. Good. All right, thank you, girls. Let me go on. Get some samples. All right, okay, let's go on. Now this one I will show you later. This is actually a shortcut, a formula lah. Just like I said, you want to remember, you want to change this one, you times, or you want to change this one, you rewrite lah. Just like the one, the Avogadro number lah. Remember, if I give you, I just tell you first lah. If the question give you moles, and they ask you to calculate what is the volume of gas. Right? I give you 1 mole, 20 moles. What is the volume of gas? What you do is you times the molar volume. What is the molar volume? Molar volume is either the 22.4 decimeter cube if it's STP, or it is 24.0 if it is room conditioner. This is called the molar volume, which is fixed. Okay, the question will tell you STP or room temperature. Don't worry. The question will tell you at what condition, whether it's STP or whether it is room temperature. You read the question carefully. The most important, you must read the question carefully. Don't simply go and do lah. Okay, the other way around. Another question can also ask you, if I give you the volume now, the opposite. I give you the volume now, you tell me, inside this volume of gas should have how many moles? So the no, from volume, you go and find the mole, right? This one, what you need to do is divide the molar volume. Divide. So what is the molar volume? Again, it's the 22.4 or 24 BMQ, okay? Depending on the situation that they give you. So again, like some people do not know how to memorize it, no worries. You do, I show you how to do. I show you how to get it based on logic. You write down what you already know. What you want to find, put on the right hand side. Put on the right hand side. Then you just do the calculation here times here, divide by there. Then you can get answer. Okay, let's do questions. Right, first one. I will show you the answer. Let's do it together. Calculate the volume of 2.2 mole of hydrogen gas, hydrogen H2 in decimeter cube at STP. Now, here, let me ask you one thing. What are you supposed to find? First things first. Are they asking you to find mole or asking you to find volume? Asking you to find mole or asking you to find volume? The question number 1, example 9 here. When you can open your mouth, you can just talk. Right? No need to so simple. And then I have to wait for your answer because you see the delay is there. So if you come in directly, I can hear you on the spot. Okay, now tell me, what are you finding? Are you finding mole or are you finding volume now? Type in there, mole or volume? Mole or volume? Volume. Okay, Cheryl says volume. All right, let's check. Always highlight your question. Highlight. Calculate the volume. Yeah, you're right. Simple. Calculate volume. Now, so you know if I give you the volume, that means you're supposed to find a molar. Your answer must be mole. Your answer must be mole. Okay? So I give the volume. Now, sorry, I give you the mole. I give you the mole because here, you see, I give you 2.2, right? Sorry, I give you 2.2. Here. I already have 2.2. You find the volume. Okay, whatever you want to find, put on the right hand side, please. Okay, so let me do this. 2.2, STP. Hydrogen gas. Let me rub this away. Yeah. So not much space. Okay, so write what you already know. What you already know is the molar gas. All right. You already know that 1 mole of whatever gas it is, this is hydrogen, will occupy how much? Will occupy, this is STP, STP is 22.4. Okay, 22.4 decimeter cube, the volume. Now, you're supposed to find mole now. So when I want to find mole, I must put on the right hand side. So I go to balikkan this equation. Instead of putting 22.4 on the right hand side, I go and put here. It's the same thing, just left or right only, all right? Equals 1 mole. Okay, of hydrogen. Okay, so I don't need this one. I don't need this one because I want to, like I said, whatever I want to find out, I put on the right hand side. It's easier. Okay, please follow my rule. This is proven, tried and proven. Okay, next one. What is the question they give you? Terbalik. Oh, they give you the mole. Ay, so sorry, girls. What happening to me? Ay, this one don't need. Use the first one. Use the first one. This one was correct. Yes. You're supposed to find the volume. Sorry, girls. Okay, now this one. All right, this one. 2.2 now. They tell you it's 2.2 mole. 2.2 mole of hydrogen, it should occupy how much space leh? One mole, it occupies 22.4 because this is STP condition. So if it's 2.2 leh? Okay, go type your answer. And don't forget, grab a calculator. All these lessons I need calculator one. Even very good in maths, then no need lah. But better check, better double check. Sometimes we make mistakes when you do manually. Okay, have a calculator ready. 2.2. How do you do this? So this one times this divided by that. 2.2 times 22.4 divided by 1. Okay. Click away. 2.2 times 22.4. Answer. Type your answer here. What is your answer? Wait for you. Don't be scared. You may not be wrong. You could be correct. Right? Simple 2.2 times 22.4. What's the answer? Okay. No answer. Show you Answer is 49.28. Now what is the unit? Yeah, I got the answer already. Who answered this? Okay, good. All right. Yeah, all right. What is this? So Cheryl. Right, okay, your answer is here. 49.28. Okay, so let me show you. 49.28, what is the unit? The unit is here. Follow what is here. That's why I say put on the right hand side. What you want to find, put on the right hand side. It is DMQ. Yeah, all right, okay, simple. The most important, you must know what you're looking for. 49.28. Okay, let's go to another one. Let's go and try another one. What? Don't you answer. What is a mole? What is a volume of 0.01 mole of ammonia gas in cm cube at room condition? So underline what you're given. You are supposed to find the volume. What is the volume? It's our volume and Tarso room condition. Now look, observe here, we don't need the Avogadro number because they're not asking for how many particles. They don't ask you how many particles are there in 1 mole or 0.01 mole. Don't have. If they ask you for particles, got how many molecules, how many atoms, or how many formula units, or how many ions then you will need your Avogadro number. Otherwise, you don't need. You only need if you want volume, you need the molar mass. Okay, if you want volume, if they want the mass, how many grams, you will need the RMM, the relative molecular mass, or the relative formula mass. Okay, so we go on to this one. 0.01 is ammonia gas, room temperature, room condition. 0.01. Okay, let's check. What you already know now, the same thing. You already know 1 mole. 1 mole is 1 mole. All right, where is it? Okay, now I'll put red. 1 mole of what gas? Ammonia, NH3 is 20 what? Room condition. Room condition is 24. Okay. Decimeter cube. Okay, now they give you how many moles? 0.01 mole. Okay, NH3. Same thing. No need to remember it's times or divide. As a shortcut one, actually, already show you just now. So now you just times this one times this divided by that. 0.01 times 24 divided by 1. And your answer will be 0.01 times what? 24. 0.24 decimeter cube, right? But now I say this is smaller than one decimeter cube, isn't it? So you can convert it into centimeter cube if you want. Okay, so because it's less than 1. So how to convert? Remember, 1 decimeter cube is how much, how many centimeters? 1 decimeter cube is how many cm cube? Okay, we saw just now earlier on. Where is it? Where was it? Here. Right? You remember this? So if I do not want my answer in decimeter cube, I can convert it into centimeter cube. So I just need to times 1,000. So your answer will not be 0 point something lah. It will be 0.01. Yeah, okay. So it will be what? I times 1,000. I just times 1,000, this number, and I will get, okay, I will get 24, this one, 1, 2, 3, 2,400, is it? Centimeter cube. Let's check. No. Oh, 0.01 times 24 is 0.24. 0.24. I times 1,030. 1, 2, 3. 1, 2, 3. Okay, 240. 1, 2, 3. Yeah, correct. 240. There. Okay. You get it? So you see, if I want to convert mole, right, into volume, converting mole into volume, I give you the mole, you find the volume. What you need to do? You have to times the molar mass, times the not molar mass, molar volume, times the molar volume. Okay, same thing like just now. I give you the mole, you find the volume, you have to times the molar volume, times. Understand? So same like this, like that. Here, this is the formula. I give you the mole, left hand side. I find the volume, all right? I have to times the molar volume. Itu dia. That's all. And then the other side of the question, I'll give you another one, is what if the question wants you to find the mole? They give you the volume and you find the mole. All right, then you're going to divide, okay? But if you don't remember, again, you do the logic like what I did. I didn't have to remember this. I just do that equation there. Okay, let's look at the next question. This is also molar, so example 12. Okay, I skip the example 12. I go to the next one. I go to the next one where you're supposed to find what? You're not supposed to find another one. You're supposed to find the volume of gram. I don't know, another one. Where's it? Where's the other one? Sorry. Here. Now you're supposed to find mole. Yeah, correct. You're supposed to find the mole. Now the next question is you're supposed to balik. You're supposed to find the mole now. Okay, you're supposed to find mole. Right. So the mole here is, you're supposed to find the mole, all right? And they give you the volume. The volume is given to you. Why am I so fat? Okay, more colors. Okay, never mind, just leave it like that. Okay, so you are now to balik. You are given the volume, right? You're given the volume, you're going to find the mole. Okay, so no need to remember times or times or divide. Now look at room condition. Okay, I just remember this room condition, 600 oxygen. Okay, so I do this. Yeah, where your workspace? Okay. What I know is what? Now I know is 1 mole oxygen. I will have, this is STP, room condition. What is it? Yeah, sudah lupa. Right, sorry. Room condition. Okay, room condition. Room condition will be 24 decimeter cube. This is room condition. Okay. Now you're supposed to find mole. Right? Supposed to find mole. If you're supposed to find mole, like I said, what you want to find, put on the right hand side. So don't write like this. Go and terbalik kan, write like this. Fine. Is 1 mole, right? 1 mole oxygen. Now, so they give you how many decimeter cube now? They give you how many decimeter cube? 600 cm cube only. 600 only, not even decimeter cube. So it's 600 cm cube now. But you see, different unit, right? Different unit, you cannot just simply do like that. You have to convert into same unit. Okay, how to convert into same unit? So just now remember 1 decimeter cube is 1,000 centimeter cube. So if I want to convert my cm into dm, I need to divide. Okay, I need to divide. So I need to divide by 1,000. Then this one automatically will become dm cube already. Then only I can put it in. Okay, and this one becomes 0.6, if I'm not mistaken. So this one becomes 0.6. So I just change this, easier for you to do calculation afterwards. So this is actually 0.6. Okay, then I times here. If I don't want to remember whether it's times or divide, I just do this from the left-hand side. I times here, I go and divide up. Okay, so 0.6, or if you want to remember, is 0.6. Okay, this is this one here, times 1 divided by 24. Okay, yeah, 24, correct. So this is actually 0.6, 0.6 divided by 24. Okay, so do your punch your calculator and see what's the answer. 0.6 divided by 24. You get a very nice number. It is like a definite number. We don't have a number that is extended until cannot finish. Okay, infinity. What is the unit here? What are you looking for? Tell me, what are you looking for? You're looking for what? You're looking for here? Look at on top here. That's why I push everything to the right. So mole. So 0.025 mole. So if I have 600 centimeter cube of the gas in a certain container, inside there should be only 0.025 mole. Okay, it's not even 1 mole yet. Understand? All right. So let's look at the answer. Here, let's look at the answer. There. 0.025 mole. Okay? Can or not? Okay? I don't like to look at all this calculation like too complex. So I always do it my way. My way is always, okay, X is Y. Or X, A is Y. Then my B, my B will be B times Y divided by A. So I don't need to see all these things. Right? As most important is to see your final answer. Okay, just look at your comment. Is any questions there? Do you want me to repeat any part, or shall we go to and do some questions? Some more questions. I have, by the way, prepared some questions for you in the Google Classroom. So please go and practice this. Right? Otherwise, it's just wasted your time. These 2 days, you learn so many things about it. When school reopens next month, I think you will have forgotten if you don't practice. So please do your exercise. Okay. I've given you about all in total about 4 exercises already. So please do it. I will mark it at my leisure time during the holidays. Okay. Now, any comments before we start? I give you one sample question. Let's do it. Okay. This is one of the questions in your exercise. So it doesn't matter. I just do one now. Okay. Now see what information you're given. Whenever you want to do these kind of questions, they will always give you the molar volume, right, of the gas. Whatever STP will be 22.4. At room condition, it will be 24. Okay, and also they always give you the Avogadro number, so you don't have to memorize that. Don't worry. Another thing they will always give you is the relative atomic mass of each of the different elements. Okay, hydrogen is 1, oxygen is 16, sulfur is 32. Okay, potassium is 39, calcium is 40. And that's why I remember, because I've done so many questions. You will remember. And the more you do, the more questions you do, you will remember all these things. Okay, let's do the first one. Calculate the volume of 0.6 mole of chlorine gas at room condition. Doesn't matter what gas it is. This is not important, so I rub it away. What is important is what I underline. You're supposed to find the volume. Okay, that means you must be given the molar. If they want you to find volume, they must give you the mole. Otherwise, you cannot answer. Unless they give you the mass. The mass, you can also find volume. They give you the mass of the substance. You can change it into the what? Change it into the mole. Then from the mole, you can change the volume. So that will be my next lesson. Next lesson is more complicated. How with the 3 things we have learned there, how you can pushing. The 3 things can pushing. The number of moles. Then after that, the Avogadro number. Then after that, the mass, molar mass, and also molar volume. Okay, today you learn the molar volume. Okay, let's do question 1. If anyone can answer, you can please put your answer here. What is the volume of 0.6 mole of chlorine gas at STP, 那两个 question at STP also need to count. Room condition also need to count. So there are actually 2 questions here. What is the volume of 0.6 mole? All right, let's see. 1 mole is how much? Always write what you already know. This is fixed chlorine gas. Is what? This is for what? What condition? Okay, STP first. Do the first one. There are 2 questions here. At STP, STP is 22.4 decimeter cube. Okay, this is the volume. Volume of 1 mole of chlorine gas at 22.4, it will be 22.4 decimeter cube. Now, if it is 0.6 of chlorine gas, it will be how much? It will be here, so this times this. So you got 22.4 divided by 1. So your answer will be, okay, I won't show you the answer lah. You can do it yourself because it's supposed to be exercise. Okay, then you do another one because they ask you and room condition. Right? So this is another one. So room condition, right down here at room condition, or you can just put at room condition, or you can say at STP. Okay, if you don't want to put at top here, you can put 1 mole of chlorine gas is 24 decimeter cube at room condition. At room condition, RC, just put it for short. Okay, now if it's 0.6, 0.6, same thing. That's so easy, right? First question is always the easiest. Okay, so 0.6 will be 0.6 times 24 divided by 1. So you will get your answer. And what is the unit? Don't forget your unit. If you don't write your unit, no matter how beautiful, how correct your answer is, it is wrong. Okay? In science, you always must write your unit. So how to get your unit? Look up here. This is what you want to find. So it will be dm cubed. Okay, is it clear or not? Okay, so now, this is exercise. Right now, before I let you go, I need to tell you how to, all these 3 things are interconnected. In fact, there are 4 things here, right? First of all, you learn the number of moles. The number of moles means in the Avogadro constant, number of particles is fixed. Okay, 1 mole here, 1 mole here means I have 6 to the 6.03 times 10 to the power of 23 什么东西? It can be atom, it can be molecule, it can be ions or formula unit. Okay, that's number of particles. And later on, we learn about the mass. Okay, 1 mole of the substance will also have a fixed measurement of the value of the mass. And how do we get this? We look at the RMM or RFM. If it is water, it will be 18. So 它的 gram 就会 18. Okay, if it is, let's say, RFM, sodium chloride. Yeah, sodium chloride. Sodium chloride, if you calculate the relative atomic mass, is sodium is 23. Then the chloride is 35.5. You're going to get 58.5. Then the mass of this 1 mole will be 58.5 grams. Okay, clear? This is what you learned yesterday. Now, today we tie in another one, which is a volume. All right, let's summarize everything. The volume here is, if it is STP, right, 1 mole of gas. This is only for gas. You cannot get you cannot measure, you cannot have that volume. It's not true for solid and liquid. Okay, so 1 mole of gas, that's oxygen, at STP, it will have 22.4 decimeter cube, or if it's at room condition, it will be 24 decimeter cube. Okay, so these are the things that all the things are pushing on. Right? The next time the question you're going to see here is, I give you the particle, all right? I give you the particle. I don't ask you for mole. I don't ask you how number of mole. I ask you this one. What is the volume of gas? Also can. You know how? I find the mole first, and then from the mole, I go and do this. Okay, that's one way. Or, example, I give you the mass of the substance. I give you the mass of the substance, right? I give you the mass of substance. Yeah, cannot rub. Okay, give you the mass of substance. I don't ask you for mole, but I ask you straight away, guess volume 是多少? So how do I do it? What you can do is 这个 mass 好像跳过去哦 volume. What you can do is you convert into mole first, and then from here convert to here. You can still find. So here all the four things are pushing one. That's why a lot of students, don't know how to do because they pushing 太乱了. Alright, so in my next lesson, I'm going to do it sometime next week lah. So like I mentioned just now to those who came in earlier, I'm going to have some more lessons in the holiday because I find that this is very important for you to learn. So they don't, first month, go into chemistry and say, wow, everything I don't understand. A lot of things you don't understand because this is a bit complicated. Especially if your maths are just so only. Your maths are not strong. Your concept of this one is not strong. You're going to be lost later on. So I want to do some more classes. I don't mind. It's free classes, right? Anybody can join. You can give your friend also. You can tell your friend to join. You can be from different school. Doesn't matter. I open to everybody. All right. Please tell your friends you join out the class. Just enter whenever I have a class. If you subscribe to me, you will get the notification. If you don't, I'm going to send a message to your group to let you know. Okay, I'm going to have class when. Just tell you want to join in, or tell your friends from different class or even from different school. Okay, you just join in and then you can learn up now. Okay, so the next thing I'm going to teach you is this one. All this. I give you mass. Now you tell me what is the Avogadro, the number of particles. Or I give you number of particles, you directly go and find the volume. Okay? You no need to find they didn't ask you for mole. They asked you to find the volume. So there's this pushing. It's a lot of questions. All right, okay. So in the meantime, please do your question that I've given in the Google Classroom. Understand? Now, these are all the examples here. So next lesson, I will go through all these examples. Examples and give you some more examples. All right, some more examples and do the questions. The last one maybe you cannot do yet because unless you're very, this is the last one, the last set of answer questions here. The last set of questions here is based on this one now. So all these four things, pushing, convert from here, convert to this, convert to that, and so on. Understand? All right, okay. So please make sure you have written your your attendance and your name there, please. Otherwise, I will record you as not being attending my class. Okay. So next week I will have I think one class and 1 or 2 classes a week lah. Okay, either way lah. So you please let your friends know, let them join in. It will be on my YouTube channel. So just log in lah. Click on the link. You can see again also. This is all repeated. You can you can see the recording from time to time. Okay. From any time, so no problem. You can share it also if you want to. You can share to anybody. Okay. Any questions? It's almost time. Okay. Okay. Siti Rahima said yes. No problem. Is it any problem? Any problem? Please ask. Or you can message me on your group chat. Okay. I will explain to you. All right. If there are no questions, then I will see you in my next lesson where I will explain even more questions related to all these 4 things that we can actually interchange and you can convert and find all the questions. So the clue here, the most important thing is you have to do questions and you have to practice. Okay. Otherwise, you are going to be lost. All right. Okay. I'll see you next week then. Okay. I'll see you next week. So bye-bye. Bye-bye. See you next week. Okay. Yeah, welcome, Cheryl. Welcome, Chaying. Okay, I'll see you. And please do your questions, Okay, please do your questions. All right, welcome. All right. Okay, I can take attendance now. You can leave the what? I will take attendance. Okay, bye-bye.